Greetings, everyone. My name is Kadiravan Selvam, and my metric number is A169712. Today, I'd like to explain about my project A of finite element analysis. Okay, before we go into further explanation, I'd like to give you a brief introduction about the project. Okay, on construction site, tower cranes are frequently utilized to lift items. The majority of buildings sites are small and accessible to the public. Tower crane accident put pedestrians as well as the workers at the construction site in danger. This accident came along with high financial losses, serious injuries, and the crane repairing part. Okay, in order to minimize this loss and save the workers' life, we like to run an analysis about the stress and how the wind affect the crane. For problem statement, in our project, we are trying to solve how the wind speed may affect the crane, and also we are trying to find about the stress that the crane undergoes on a certain speed of wind. The objective of our project is dynamic analysis of the crane structure based on the wind research result as requested by the client, and the maximum deflection of beam under static loading of 1 meter. For methodology, the geometry of the crane as shown in figure is based on our student metric number, which is the last two digit is used. For the length of the beam, 20 plus 10 times 1, which is 30 for the length of the beam as shown in the picture. And for the mass, we use 20 meter for the mass length. The angle of the crane is set to 15 degree as our liking because there can be any degree that we want to use. Okay, for the max point load is 200 kg or 20,000 Newton. And for assumption, we assume that the material of the crane is structural steel and the meshing size is 0.5 meter. And we'll be using ANSYS software to solve this project. Besides that, said that there are a few crane specification, which is the cross section. We use 0.05 meter as our cross section for the crane, and the length of the counter jib is 33 meter. Okay, let's go into ANSYS software for the simulation explanation. As for the ANSYS simulation, first we need to build our geometry as follow the length that given before. Okay, first of all, we need to put the force on the end of the crane, which is 20,000 Newton, and the countermeasure is 25,000 Newton. And we need to fix the bottom point of the crane so that the total deformation won't deform a lot, since since the actual crane will be fixed at that point. So the total deformation was at 0.065172. Okay, let's go to after settle our static analysis, let's go for the harmonic response to see how the wind affect the crane. As you can see, we input the wind speed as 1 ms -1, and okay. So this is the graph we obtained. As you can see, and this is the graph for the response. We run 3 responses, and we got these 2 graphs. As we know, there is a deformation, there is a slight stress when the wind blow on this when the wind blow at 1 ms -1 on the crane. For conclusion, as a conclusion, the use of ANSYS software was incredibly advantageous for analyzing the framework of a crane tower.
When a force of 20,000 Newton is applied, a maximum deflection of 2.9584 m is obtained using static analysis. An increase in applied force would make the tower crane structure unstable, creating a dangerous condition that could threaten the safety aspect. In terms of harmonic responses analysis, the frequency response varies according to the three zone of the boom, the design of this tower crane, and the impractical for real world utilization as a deflection in a large and structure would experience a major instability which could result in a precarious situation. Okay, that's all from me. Thank you.